All right, this should be 5. 5-2 number, back number 7. Here we go. Put in an angle. Guys in the back. Guys in the back who love to pay attention. Pay attention now. I'm going to put in a 0. Here's the pen. That's not good. All right, 0. Put in a 0. I can put a 0 the first one. Sign of 0 is 0. 2 times 0 is 0. 1 plus 0 is still 1. Put it in for the other one. Same thing happens. Sign 0 is 0. Plus 2 is 2. Now I'm going to go, pi over 6, which is a half. A half times 2 is 1. 1 plus 1 is 2. Put it in there. I get 2.5. So far, so good?
Wait, do you know this, what it is, the sign by heart?
Yeah, you're supposed to too.
By heart? What do you mean? I would lose my calculator right now.
Yeah, but you should be able to do it by heart because you know that pi over 6 is 30 degrees. You know, sine of 30 degrees is a half.
Okay, so I just like this.
I made you do it too, so you'd be a super cool science, whatever you said. All right, pi over 3. Why wouldn't it be a math super cool rather than
Math is not super cool.
All right. So I put it in there. I get root 3 over 2 times 2, which is about 1.7. Plus 1 is 2.7. I put in root 3 over 2. I get 2.86, like 2.9, just outside of the bounds. And now I'm going to do pi over 2. Pi over 2, I've got what? Pi over 2, I've got 1, which gives me 3. I've got 1, which gives me 3. By the way, I just found a point of intersection. That's going to be a point of intersection. We already got it. Not even working too hard. Then I'm going to go 2 pi over 3. 2 pi over 3 is in the second quadrant. I'm going to get myself 2.7 and 2.9 again.
That's 3. I got 3 again. For pi over 2.
Right. Got 3 and 3. That's actually a point of intersection.
I'm guessing we're gonna have 2.
And then I'm going to go, next one will be 5 pi over 6, which gives me 2 and 2.5. Am I wrong? Sure to wait? We're all good?
Wait, what's the one that's before pi over 2?
Pi over 3? I'm just literally going around and I'm doing all the points around the outside.
Should you always do the whole thing, or can you kind of get like what's going on?
What, as I said before, once you got one of the shapes and you got the pattern, you're done, right?
Just reflect it.
Yeah, well, depends on what shape it is, right? What you're looking at. You got to keep doing it until you know what you're looking at. That's all I care about. So sine of pi is 0, so that gets me back to 1 and 2. So that part's symmetric. Well, I'm running out of space. Let's just keep going right over the top of Michaela is designing a border for her stationery. Good luck with that. 7 pi over 6. 7 pi over 6 would be, negative 1/2. So negative 1/2 gives me negative 1, which gives me 0. Negative 1/2 gives me 1.5. What's the next point? 4 pi over 3. I might as well just give up on that part. Let's go ahead and I'm going to write it over here. I'm going to finish it up over here.
4 pi over 3.
Yeah, let's do 4 pi over 3. 4 pi over 3 would be about 0.866. So negative 0.866, 2 times that would be negative 1.7. So I get negative 0.7 for the first. And for the second one, I'm going to get negative 1.1. No, positive 1.1, right?
Yeah.
Who did this? Somebody should be checking me. Okay, good. Then I go 3 pi over 2. 3 pi over 2, it would be negative 1. So that gives me negative 1 for this and gives me 1 for this. There we go. How are we doing? Still good? So then I go 5 pi over 3. 5 pi over 3 would be 60 degrees, so it's still going to be a negative 0.8. So I'm going to repeat these two, aren't I? And I'm going to keep going. I've got 5 pi over 3. The next one would be 11 pi over 6.
That's the last one.
And 11 pi over 6 would be 0 and 1.5. All right. Is there? I don't see any. Try it.
There's one.
Let's try them. Let's try them. We know one. Yeah, we know one. So I'm going to go orange first. Orange is going to be the first graph. It starts at 1 with not an eraser but with a pen. Starts at 1. Goes to 2. Then to 2.7. Then to 2.9. Wait.
No,
I went too fast here. What did I miss a point?
No, you're good. 2.7.
2.7 and then 3. All right. 3 and then down to 2.7.
2.
Then 2. Then 1. Then 0. Then it goes to negative 0.7. So negative 0.7 at 4 pi over 3. So negative 0.7 put me over here. Negative 1. Negative 0.7, then back to 0. So this is a Le Maçon. Looks something like this. Le Maçon.
Wait, what was 4?
Fake cardioid, right? Fake cardioid. Now let's do the other one. The other one starts at 2. 1, 2. Goes to 2.7.
Wait, what? 2.5.
Yes, it goes to 2.5. I'm not even reading it. That's good. 2.5. That's exactly what I drew. 2.9. 3. So that's a point of intersection. So now I got at least one point of intersection. I can even tell you where it is, which is interesting. Usually you can't tell where it is. 2.9 would be here. Then 2.5.
Wait, it goes to 3, right?
That's 3. They touch here. So now down to 2.5. Then I go down to 2. Then I'm down to 1.5. Then I'm at 1.1. Then I'm at 1. Then I'm at 1.1. Then I'm at 1.5. I come in, make my cute little heart, make myself a cardioid. So from this, without any algebra at all, what's my answer?
1.
Pi over 2,
Yes.
right? And so it's going to be 3 pi over 2 is what my expected answer would be,
Wait, so what?
right? Because we do r theta, 'cause the
Oh, right,
stupid
right,
guy
right.
got it wrong in the first
I
place.
didn't see the comma. I thought it was like
Yeah. Oh, sorry.
How did you get that?
Where do they cross?
Oh, that's why.
That's it. Remember way back when we did graphs back in algebra 1, algebra 2, where they cross is what the solution for the system is, right? Then we also learned how to do it algebraically. So
The point is, right?
where the points cross, right? So now I'm going to do it algebraically. Algebraically, we do isolate a variable. Well, this is really easy. They're both isolated already. Set one equal to the other. So I would go 2 plus sine theta equals 1 plus 2 sine theta. With me so far?
Wait,
This is just another way to solve it, right?
Another way to solve the same thing. Yes, ma'am?
why is it 3 pi over 2 and algebra is -1 and
It's 3. What? That's not the same.
Yeah.
The point is 3 from the center, and pi over 2 is my angle. Yeah?
Got it.
Remember, they asked to do the radius first, which is,
There
again,
should be a
not my
comma
favorite.
in there. Oh.
There is a comma. I even made it bigger because people struggled with the comma. That make sense?
Yeah.
Good. All right, now I'm going to go ahead and do this. I go 2. So I solve this. So I go 2. I subtract the 1 to both sides. Actually, let's do the signs first. So subtract the sign first. I get 2 equals 1 plus sine theta. Move the 1 to the other side. I get 1 equals sine theta. The problem says between 0 and 2 pi, where does sine give me 1?
90 degrees.
90 degrees, which, since we're on radian land, would be Pi over 2. So that's how I get that point. Theta equals pi over 2. Now how do I get the R value? Plug it back into one of the equations, just like you did in Algebra 1.
Just one of them.
Either one will work, right? It's got to work for both, right? So I put a pi over 2 in this one. I get R equals 2 sine pi over 2. Sorry, 2 plus. So that's 2 plus 1, which is 3. And that's how I get that answer. Make sense? In a painfully making what I was nice in Algebra 2 sort of way in a much harder way.
So we have to do both ways.
Yes, it has to do both ways. Do it both ways. Second one, you're going to almost have to do it both ways.
But is it plus 2 sine theta, or does it not multiply together?
What are you talking about?
Like when you want, like made it equal one another?
Yeah.
Theta, what did you do to the 2 sine theta?
Well, I subtract sine theta from both sides. That gives me sine theta. Then I subtract 1 from both sides. Just did algebra. Algebra. Make sense? Other questions? All right, try the other one.